The world is staring skywards. Europe is launching its first ever planetary defense drill as interstellar visitor 3I Atlas barrels through the solar system. A cosmic stranger is triggering a global wake-up call, and humanity is rehearsing for the ultimate what-if.
In late November 2025, the United Nations, through international space safety networks, triggered a planetary defense drill unlike anything before in human history. And it wasn't about war, terrorism, or climate disaster. What put Earth space agencies on alert was the sudden appearance of an interstellar visitor dubbed 3I/Atlas, the third confirmed object ever observed to come from outside our solar system and whisk past our cosmic neighborhood. Europe became the focal point for this unprecedented exercise, with multiple nations coordinating observational and tracking scenarios to see how well the planet could respond if a real threat ever loomed. Official announcements made clear, 3I/Atlas poses no danger to Earth's safety. Yet its passage sparked the largest coordinated planetary defense readiness test the world has ever seen. A strategic warning echoed from Brussels to Washington and beyond. The big question now gripping scientists and policymakers alike is simple but chilling. Why would a harmless space rock trigger preparations for a potential extinction-level event? Atlas did not arrive with explosions, warnings, or dramatic visuals in the night sky. It appeared quietly, first as a strange data point, then as a confirmed anomaly buried inside streams of astronomical data. Scientists quickly realized this was not just another comet drifting through the solar system. It was the third interstellar object ever identified. Following Oumuamua in 2017 and Borisov in 2019, each arrival rewriting assumptions about how isolated our cosmic neighborhood truly is. Like its predecessors, Atlas did not originate here. Its trajectory showed no sign of being gravitationally bound to the Sun before entering our neighborhood. It came from deep space, carrying momentum shaped by forces far beyond our planetary system. At the time of public confirmation, it was already about 170 million miles from Earth, far outside any danger zone. Calculations showed it would reach its closest approach on December 19, 2025, still well beyond Earth's orbit. Every model agreed on one point: there was no collision risk, and yet reassurance did not bring comfort. Because the concern surrounding Atlas was never about distance, it was about meaning. Interstellar objects challenge a dangerous assumption humanity has relied on for decades: the belief that threats give us time. Most known asteroids orbit the Sun and can be tracked years in advance. Atlas did not follow those rules. It entered fast, from an unexpected direction, and reminded scientists how little control we truly have over what comes from beyond the solar system. Its appearance exposed a fragile truth. Earth's detection systems are improving, but they are not complete. Blind spots still exist. Response chains remain slow. If an object like this were slightly larger, slightly closer, or detected slightly later, the outcome could be very different. That is why unease followed Atlas, not because it was dangerous, but because it was harmless this time, and that raised a question governments could no longer ignore. If this was only a visitor passing through, why did it leave the world feeling suddenly unprepared? From the moment 3I/Atlas was confirmed, scientists were clear about one thing. This object was not a threat. Its trajectory kept it far from Earth, its size posed no danger, and every reliable model showed zero risk of impact. In scientific terms, the case was closed almost as soon as it was opened. Public statements reflected confidence, and the data supported calm. But the story did not end there. Because while 3I/Atlas itself was harmless, it proved something far more unsettling. Objects from outside our solar system can appear with little warning. They do not follow the slow, predictable paths of most asteroids that orbit the Sun. Interstellar visitors arrive fast, often traveling tens of thousands of miles per hour, carrying energy shaped by environments we do not fully understand. Their paths cut through the solar system at sharp angles, making them harder to spot until they are already close. Even a small change in lighting conditions or observation timing can delay detection. This breaks a dangerous illusion of control. Most planetary defense strategies are built around known patterns. We track objects that loop around the Sun again and again. We study their orbits years in advance. Interstellar objects do not play by those rules. They come once from far away, and they do not slow down for us to react. That is where the real risk lies. Detection systems have improved, but they are not complete. Large areas of space remain poorly monitored. Some objects approach from directions where telescopes have blind spots. Others are simply too dark or too fast to notice early. 3I/Atlas was detected in time, but it easily could have been missed if conditions were slightly different. That is why scientists describe 3I/Atlas as a warning, not a danger. It showed what is possible, not what is imminent. It reminded policymakers that the next interstellar object might not announce itself so clearly. And that leaves one question hanging in the air. If humanity was lucky this time, what happens if the next one is not seen at all? As the Planetary-Defence drill moved from theory into action, Europe emerged as the central stage of an unprecedented decision. Under coordination frameworks linked to the United Nations, the continent became the largest testing ground for a scenario that had never before been rehearsed at this scale. For the first time, a space-related disaster was treated not as a scientific curiosity, but as a continent-level emergency exercise that demanded political attention and real-world coordination. 27 European nations took part simultaneously. This was not limited to space agencies tracking distant objects through telescopes. Defense ministries were involved. Military radar systems were integrated. Emergency response forces prepared for cascading consequences that could stretch far beyond the initial event. Civil authorities, communication networks, and crisis planners were pulled into the same framework. The drill connected institutions that rarely operate under a single command structure, forcing them to communicate, share data, and make decisions under pressure. Often without complete information. What made this moment extraordinary was its intent. This was not a research project designed to collect academic data or refine scientific models. It was a stress test of governance itself. Officials wanted to see what would happen when governments faced a threat with no historical playbook. How fast could information move across borders? Who had authority to act first? What happens when minutes matter and uncertainty dominates every decision? By choosing to run this exercise at a continental level, Europe sent a clear signal. The risk was no longer theoretical. Even without an immediate threat, leaders acknowledged that space hazards belong in the same category as other existential dangers. Ignoring them was no longer an option. This shift revealed something deeper than concern over a single object. It showed a growing belief that preparation must come before certainty. Waiting for proof could mean waiting too long, and that leads to a question that still has no easy answer. What convinced Europe that remaining on the sidelines was no longer safe? The scenario used in the drill was deliberately unsettling. Planners chose a hypothetical object similar in scale to 3I/Atlas, but placed it on a far more dangerous path. The goal was not realism for comfort, but realism for consequence. Officials wanted to understand what the worst case might truly look like if luck ever ran out, and what decisions would have to be made when no perfect options remained. According to the simulation, a direct impact from an object of that size could release energy comparable to multiple nuclear warheads detonating at once. Unlike conventional weapons, this force would not strike a single city or region. The shockwaves, heat, and debris would ripple through the atmosphere. Oceans and climate systems, fires could spread across continents, tsunamis could cross oceans. Even regions far from the impact zone would feel the consequences as global systems began to fail. What made the scenario even more disturbing was the absence of a familiar enemy. There would be no opponent to negotiate with, no ceasefire to declare, and no border to escape across. A space impact does not recognize politics, alliances, or neutral ground. Its effects would spread globally within hours, touching nations that had no role in the response and no control over the outcome. This reality forced a difficult conclusion. No single country, no matter how advanced, could handle such a disaster alone. Early detection, decision-making, and response would have to cross borders instantly. Any delay caused by confusion, disagreement, or lack of coordination could multiply the damage beyond recovery. That is why the drill treated the scenario as more severe than war. Wars end. Space impacts do not negotiate their way out. As the simulation unfolded, one question remained impossible to ignore. In a real situation like this, would humanity actually have enough time to react? One of the most critical elements of the drill focused on something rarely discussed in public: data integration. For the first time at this scale, military radar networks were linked directly with astronomical observation systems. Tools designed to track missiles and aircraft were repurposed to monitor objects far beyond Earth's atmosphere, shifting their role from national defense to planetary awareness. These systems were never built with asteroids or interstellar objects in mind. Military radar is optimized for speed, precision, and immediate threat detection within Earth's airspace. Astronomical instruments, by contrast, prioritize long-term observation and accuracy across vast distances. The drill tested what would happen when those two worlds were forced to work together in real time, sharing information across systems that normally operate in isolation. The objective was simple but daunting. Could existing technology detect a fast-moving object coming from deep space early enough to matter? Interstellar objects travel at extreme speeds and often approach from unexpected angles. Some move too fast to be tracked smoothly. Others appear suddenly against crowded star fields, blending into background noise until they are already close. By feeding radar data into space monitoring networks, planners wanted to see if detection windows could be shortened by hours or even days, time that could mean the difference between response and helplessness. As this integration unfolded, a deeper shift became impossible to ignore. The traditional boundary between science and defense began to blur. Systems built for warfare were now being tested as tools for planetary survival. Space was no longer treated solely as a place to explore, study, or commercialize. It was being recognized as a new domain of risk. That realization carried weight. Risks from space do not follow human timelines or political cycles. They arrive on their own schedule, indifferent to readiness or debate. The drill made clear that preparation depends not only on better telescopes, but on faster decisions and seamless coordination. And that raised a sobering question. When seconds and minutes define survival, is today's technology truly fast enough to save humanity? As the drill concluded, officials described the exercise with a phrase that carried unusual weight: a wake-up call. Not because a disaster was imminent, but because the illusion of safety had quietly faded. 3I/Atlas was never a direct threat, and experts made that clear from the start. Yet its arrival exposed something far more uncomfortable than danger itself. It revealed how fragile human readiness still is. Space does not send advance warnings. There are no schedules, no diplomatic signals, and no countdowns designed for our convenience. Objects move when physics allows them to move, not when humanity is prepared to respond. The appearance of 3I/Atlas reminded governments that awareness does not equal readiness. Knowing something exists is not the same as being able to act in time. In many ways, the drill showed how quickly confidence can collapse once assumptions are tested. The exercise forced leaders to confront a difficult truth. Waiting until a real impact scenario unfolds would be too late. Decisions would have to be made with incomplete information, under pressure, and across borders that were never designed for rapid cooperation. In that environment, hesitation becomes a liability rather than a safeguard. This marked a shift in strategic thinking. Space hazards were no longer framed as rare events for scientists to debate quietly. They were acknowledged as risks that demand planning at the same level as other existential threats. That change did not come from fear of 3I/Atlas itself, but from recognition of how easily a similar object could arrive without enough warning. The wake-up call was not about panic, it was about timing. Preparation must happen before certainty, not after impact, and that leaves a final question hanging over the exercise. Was this drill a one-time response to an unusual visitor, or the first step in a new era of planetary readiness? Beyond the immediate headlines, the Planetary-Defence drill marked something more permanent. It laid the groundwork for long-term strategy. What began as an astronomical observation had evolved into a policy discussion, and the transition mattered. Planetary defense was no longer treated as a distant, speculative concept reserved for science fiction or academic conferences. For the first time, space was openly framed as a security factor. This shift changed how governments talked about risk. Astronomical objects were no longer seen only as subjects to study, catalog, and observe. They were recognized as variables that could influence global stability. That recognition altered policy thinking, pushing leaders to consider scenarios that once felt too unlikely to justify planning. The drill did not aim to predict a specific event. Instead, it tested whether institutions could adapt to uncertainty itself. What followed was a move from passive awareness to active preparation. Observation alone was no longer enough. Detection had to be paired with response. Data had to move faster than political hesitation. Coordination had to extend beyond regional interests. While Europe served as the testing ground, the implications reached far beyond its borders. Future scenarios discussed during the exercise were not limited to a single continent. A real space threat would affect supply chains, communication networks, climate systems, and global infrastructure. No region could isolate itself from the consequences. That reality forced planners to think globally, even when acting locally. This moment represented a turning point. Humanity began to accept that security does not stop at Earth's atmosphere. The risks above us are indifferent to borders, alliances, or rivalries, and that realization leads to the most difficult question of all. When the threat is shared by everyone, can humanity truly cooperate on a global scale? Or will division arrive faster than action? Atlas will leave the solar system the same way it arrived. Quietly. It will not strike Earth. It will not trigger destruction. It will not leave behind fires, waves, or a scar in the sky. From a physical standpoint, nothing about its passage will change life on this planet. And yet, it leaves behind something far heavier than debris. it leaves a question. The appearance of 3I/Atlas proved that threats from space are not theoretical ideas pulled from science fiction. They are real events governed by physics, timing, and probability. The danger does not lie in this particular object, but in what it represents. Interstellar visitors do not follow schedules. They do not announce themselves. They arrive when they arrive, shaped by forces far beyond human control. What the Planetary-Defence drill revealed is that the true variable is not space. It is preparedness. Humanity cannot choose when the next object appears, how fast it moves, or from which direction it comes. The only thing we can influence is how ready we are when it happens. Detection systems can be improved. Coordination can be tested. Decisions can be rehearsed. But none of that matters if preparation begins only after certainty is achieved. 3I/Atlas caused no damage, yet it forced governments to confront how narrow the margin for error truly is. A similar object arriving faster, closer, or later in our detection window could leave no room for debate. In that moment, hesitation would not be caution. It would be failure. This is why the drill mattered, not because it predicted disaster, but because it acknowledged vulnerability. It marked a shift in how humanity thinks about risk beyond Earth. Space is no longer just a frontier to explore. It is a domain that demands responsibility, coordination, and foresight. As 3I/Atlas disappears into the darkness beyond our system, the question it leaves behind remains unanswered. When the next object comes, not as a visitor but as a threat, will humanity be ready? Or will preparation once again come too late? Now we want to hear from you. Do you think humanity is preparing well enough for threats from space, or are we only reacting after the danger is already close? Leave your thoughts in the comments and subscribe to MindGap for more stories that challenge what we think we know about the universe.